So we're going to add functions together. First, we're going to start with adding, and notice that our f function is written right up here. So f of x is actually 3x plus 2. And the g function is actually x squared minus 2x plus 10. So when you add two functions together, f of g, f plus g to the power, or to f plus g of x is how we say that. That's the same thing as saying f of x plus g of x. So we're just going to take all of the terms in f of x and add them to all of the terms in g of x. So I'm going to do this two ways just because linearly is like how you might have learned it, but I like to stack them up on top of each other. So the first way is I could take my f of x and I'm just going to add it to g of x. So 3x plus 2 plus the whole g function, which is x squared minus 2x plus 10. Now I need to do something special here. Any ideas? Combine like terms. Who said that? Keegan, right? Good deal. Okay, so I'm going to combine like terms. What should I put first? Awesome. Why should the x squared come first? Do you know? Say that. It's the biggest. What do you mean by it's the biggest? It has the largest degree, right? We talked about that the other day when we did that standard form kind of. I think that was on your I think that was your function review, but it might have been your it was that warm up that we did the other day, right? It asked you to put them in standard form. Standard form means that the largest degreed monomial has to come first. So that has the largest degree. It's degree 2. Then what should I do? Okay, so 3x minus 2x is, so, and it's a positive x, right? Okay, and then, yeah, 10 plus 2 is 12. So this is actually x squared plus x plus 12. I am a little bit more visual. Like I just feel like I do better if they're stacked on top of each other. So I'm going to try writing it that way for you next. So I'm going to take the larger function and put it on the top because, why can I change the order? The commutative property. The commutative property says when you're adding, it doesn't matter. So I'm going to put the x squared minus the 2x plus the 10 on the top. And to that, I'm going to add 3x plus 2. The only thing that's tricky here is I need to make sure that I line up my degrees, right? So I don't have an x squared term. So I'm not going to put the 3x below the x squared. I'm going to put the 3x right below the negative 2x. And to that, I'm going to add the 2. And then I just kind of do this. And I'm just going to add them straight up and down. 10 plus 2 is 12. Negative 2 plus 3 is negative 2x plus 3x is x. And that x squared just comes down. I don't know if that helps you, but it's just a different way to look at it, right? The greatest thing about math is that you get to use whatever method works best for who? For you, right? Not for me, whatever method works best for you, okay? Are you guys good with that? Okay, let's talk about subtracting functions. So this says f minus g of x, f minus g of x, which is the same thing as saying f of x minus g of x. So remember that our f function, 3x plus 2, and from that, we're subtracting the whole g function. Now, you guys told me I can't change the order. The order is really important. So I'm going to put the g function inside these parentheses. Does anybody know why I'm putting these in a parenthesis? Yeah, I have to distribute that negative. So I'm going to put a little note here that says distribute. Okay, we have to distribute. And I kind of draw arrows. Whenever I need to distribute, I actually draw an arrow That helps my brain process that I'm dragging that negative through to every single term. So that's the first thing I have to do. So the 3x plus 2 doesn't change, but I have to take that negative and multiply it by every single term inside of the parenthesis. So negative times x squared is now negative x squared. Negative times negative 2x is now a positive 2x. And negative times 10 is negative 10. And then I'm going to do that whole combine like terms again. I'm just going to write a little note that says CLT. So my first term, negative x squared, good job. And now look, 3x and a positive 2x is 5x. And a positive 2 and a negative 10 become negative 8. What are your thoughts on that? You guys feel okay with that? Okay. So what's the most important thing here when you're subtracting? Then, yeah, distribute. So maybe even write a little note over here that says, oh, distribute the negative. So you don't forget. That is the most common mistake. You just distribute it, like you just take that negative to the first term and then you forget about the rest. Okay. All right. So now we're going to multiply functions. Our next example is multiplying. Is everybody good on that first one, or do you want me to keep this subtracting up for a second? All right. So I'm multiplying. So when I multiply functions, f times g of x, that's the same thing as saying f of x times g of x. So there are two ways that we can multiply functions. We have to think back to when you first started multiplying, like a monomial times a polynomial or a binomial times a binomial. You guys got that in your brain? No? Okay. Well, I'm going to write something up here and maybe it'll help you remember. All right. We learned how to multiply polynomials using two different methods. When we have binomials, we FOIL. Do you guys remember what FOIL stands for? Not aluminum, right?
First,
Last. Yeah, first outside, inside, last. So we could FOIL, and that works when we have a binomial, right? Two terms in each one. That's like A plus B times A minus B. That's when we want to FOIL. But if we have more than two terms in each one of our functions, the box method is probably the best way to go. So I'm going to show you the box method first, and then I'm going to show you it's kind of like a FOIL, but it's not even really called FOIL. It's just distributing. So this is what f of x times g of x looks like. I'm not going to do that one first because I think that gets confusing for you sometimes. I'm going to do the box method first. So remember let's put box over here. So with the box method, you're going to put your terms outside of the box. So I'm going to put the 3x and the positive 2 on the short side because I only have two terms. And then I'm going to put the x squared, the negative 2x, and the positive 10 across the top. So can someone remember, does anyone remember how to do this? Does someone feel like they could guide us into figuring that out? Kind of works like almost like a times table, right? Remember, like if your times table, whatever number you have on the top, you multiply it by this one on the side, and that's what you fill in the box. So I really am taking 3x times x squared, and that's what goes in the box. So 3x times x squared is 3x cubed. Good job. and I'm going to go across the top. So now I'm going to take my 3x and I have to multiply it by the negative 2x to fill in this box. So 3 times negative 2 is, and x times x is x squared. Good job. So negative 6x squared. The last box on the top, I am going to take the 10, it's positive, times my 3x. So that gives me a positive 30x. And now I'm going to move to the next row. So for this row, to get this box, I have to take x squared times 2. And that gives me 2x squared. Yeah. And then I have to take negative 2x times 2, which gives me, and lastly, 2 times 10, which is 20. Now, if we've done our box correctly, we should have something really cool that helps us combine our like terms, because the diagonals, the terms that lie across the diagonals, should be able to be combined. The two outer, the ones in the corner, usually aren't. So my first term, my leading term, the largest degree monomial, positive 3x cubed. And then I'm going to combine my negative 6x squared with my positive 2x squared. Negative 6 and positive 2 gives me negative 4. Yeah, good job. And then I have a negative 4x and a positive 30x, which gives me, I heard someone say it, positive 26x. Awesome. And then that 20 just, it's positive, so plus 20 at the end. So that's using the box method. Now, if you're not going to use the box method, or if you don't care for the box method, you can always distribute. But because you have two terms in the front of that parenthesis, you have to almost double distribute. So I draw arrows again, and I'm going to go across the top for the first set. So I have to take 3x times x squared, which gives me 3x squared. Then I'm going to take 3x times negative 2x, which is negative 6x, and 3x times 10, which is a positive 30x, and that should be negative 6x squared. Oh, did I put squared? I'm so sorry, 3x cubed. Perfect, thank you. And then I'm going to go across the bottom with the 2. So I'm going to take 2 times x squared, which is a positive 2x squared, 2 times negative 2, which is negative 4x, and 2 times 10, which is 20. And I stack them up. You could go linearly, but I like to stack them. That just helps me process. And then I'm just going to add those terms together. So 3x cubed plus, actually it's going to be minus. I have a negative 6 and a positive 2, so minus 4x squared plus 26x plus 20. Sorry, there was a bug on my desk. So if we did it right, we get the same answer. Okay, so again, I want you to use whatever method works best for you. Thoughts? Okay, some of you are still writing, so I'm going to wait a second. For the next part, for the dividing part, I want to ask you about a polynomial. So if you have a polynomial that has 2 or 3 terms, I'm going to kind of slide over here a little bit just to talk about it. What if I had something like 3x plus 6 over x plus 2 times 2x minus 5? Because that's a division problem, right? That's really, fractions are division. So before we start talking about polynomials, I want to remind you that when you first learned about polynomials and you started factoring, what was the number one thing that you always looked for first when you factored? The number one thing that you always looked for first. Yes, it starts with the letter G. GCF. Who said that? Good job. Okay, so that's what we're going to do. Whenever we have to divide our polynomials, you always want to see if you can reduce. And that means look for a GCF first. And possibly, I'm going to say that dirty F word, possibly factor. Possibly factor, okay? So we're still using the same 3x plus 2 and the x squared minus 2x plus 10, and we're going to divide them. So we're going to put the f of x in the top. So 3x plus 2 divided by x squared minus 2x plus 10. So I've already told you that the first thing that we want to do is see if we can reduce this, right? Does it have a GCF? Can we factor it? That's the first thing that we want to look at. So let's look at the numerator. Is there a GCF in the numerator? Does anything divide 3 other than 1 and 3? No, 3 is prime. What about 2? Does anything divide 2 besides 1 and 2? No, so 2 is also prime. So actually 3 and 2 are called relatively prime because they're prime to each other, right? You can't reduce that. There is no greatest common factor in there. So that just stays right like that. You cannot do anything to it. What about that trinomial? Has a 10, a 2. So the only way I could take out a GCF of 2 was if the x had a multiple of 2 on it, right? And it doesn't. What did we learn about trinomials in Math 1? Do you guys remember that you could factor them? Factoring trinomials? Do you remember how to do that? So let's kind of do just a little factor review. Just a quick, we're going to just do a quick talk about factoring. Okay, stay with me. When you have a trinomial, you can either look for a GCF or you can try to factor it by pulling out a binomial, right? You like find that term that lets you multiply a binomial times a binomial. And you do that by making a times plus chart. Do you guys remember doing that? The times plus chart, let me move that little guy right here. The multiplication comes from, when you're trying to look for your factors, you make what's called a times plus chart. The multiplication comes from whatever the A times C is, and the addition comes from the B term. Well, that doesn't mean anything unless you know how a quadratic is set up. So remember that a quadratic is written in the form ax squared plus bx plus c. So when I say that I'm going to factor it, I have to take a, whatever the coefficient attached to the x squared is, times the constant c at the end. So what is a times c? 10, yeah, because that coefficient, the number attached to that x squared is just a 1. We don't even write it. Okay. And they have to add up to the b term, which happens to be negative 2. Do you guys remember doing this? Nope. Huh? The x? Okay. All right. So you guys did this thing? Okay. Well, I'm going to continue with this because I just want to show you something. So Remember when you do this, or the x, either way, you're trying to find out numbers that you can multiply together to get a 10 that add up to a -2. So like 1 times 10 gives you 10, but it doesn't add up to -2. 2 times 5 gives you 10, but it doesn't add up to -2. And those are the only factors of 10 in terms of integers, correct? So this is not factorable using integers. So this is as reduced as it can possibly get. So we're just going to write it like it was. But I have a feeling, I have a very strong feeling that probably you're going to have to do some kind of reducing or simplifying on some of your practice problems. Okay? All right, so let's look at these 4 examples at the bottom. And I know that there is not a whole bunch of room. So I'm going to try to write really tiny and just slide over. If anyone needs extra paper, there's paper up there on the front. There's like computer paper. So we're taking f of x minus g of x. Didn't we already do that? We did that up top under the subtracting functions. We did f of x minus g of x. And when we did that, we ended up with negative x squared plus 5x minus 8. So that's really what we're going to start with. We're going to start with that negative x squared plus 5x minus 8. And we're evaluating this function for what? What number are we evaluating it for? What does that mean? Yeah, that means let x equal -3. So now I'm going to plug that in. I'm just going to plug the -3 in for the x. So when I do that, I have -3, negative outside, and then a -3 on the inside, the quantity squared, plus 5 times -3 minus 8. Remember that whenever you take a negative to a power, you have to put it in a parenthesis. So what is -3 times -3? Positive 9, right? A negative times a negative is a positive. 3 times 3 is 9. But we still have to make it negative on the outside because I have a leading negative. So this is going to be -9. 5 times -3 is -15. And I have a minus 8. Are all the signs the same? Yes. I have a -9, a -15, a -8. Same signs. Add them all together and keep the sign. So 9 plus 15 plus 8 is 32, and it's going to be negative. All right, number 2. We're doing f times g, and we're evaluating that function for the number 7. But we already found the product of f and g. What did we determine when we solved for f and g? F times g, what was our product? When we multiplied f and g together in the top, what was our product? Yeah. And we're evaluating this function for 7. That means that we're going to let x equal 7, and we need to plug that in. So I have 3 times, and replacing the x with a 7 cubed, plus 4 times, replacing the x with a 7 squared, plus 26 times 7 plus 20. Do y'all have calculators sitting out? So you can put it all into a calculator at one time, or you can use your brain. 7 squared, 49 times 7 more. 343, I think it's 1,020. I think it's 1,029. Yes, actually it is. 1,029 plus, let's see, that's 49 times 4, 49 is almost 50. So 50 times 4 is 200 minus 4. So that's 196 plus 42, 14, 182, I think, plus 20. I don't know. See if that's right. Although I think that, wasn't this a negative? Wasn't this a minus 4x? It was, because my answer is not right. That should be a negative. That was supposed to be a minus 4x. So a negative 196. So what does that equal? My brain's tired. Oh. 1029 minus 196 plus 182 plus 20. I got 1035. Yeah, okay. Okay, you got it? Okay. All right. Number 3 says f divided by g. What did we get when we took the f function and divided it by the g function? What did we end up with? Anyone? God bless you. When we took f and divided it by g, what was our final result? What did we end up with? So we just have to take that and let x equal 4. And hopefully we can simplify. So in the numerator, I have 3 times 4 plus 2. And in the denominator, I have 4 squared minus 2 times 4 plus 10. I'm going to have to write skinny, skinny for this one. Let's see, what's 3 times 4? 12 plus 2 is 14. Okay. 4 squared is 16. Negative 2 times 4 is negative 8. Plus 10 is 6 minus 8 is 16 minus 8 is 8 plus 10 is, I think, 18, right? So can I reduce that? So 7 over 9. Okay. What about the last one? Did we take the g function and add it to the f function? Yeah, when? It was the first thing that we did. We just wrote it as f plus g. Good job. I was just trying to trick you. So we're just going to take our result for the addition, because remember the order doesn't matter with addition. So x squared plus x plus 12. We're going to let x equal negative 5. So negative 5 squared plus negative 5 plus 12. So negative 5 squared is 25 minus 5 plus 12. And I think we end up with 32 again. Right? Do we end up with 32? Is that right? Perfect. Okay, so I will do, so your homework, it really is going to be due on Tuesday, this worksheet. We're going to try and do some of these together, but we have got to do some journal entries really fast. So I'm going to try and turn on this document camera, and I'm going to put my journal up here. Oh, I didn't want to do that. What's going on? Yes. Yes.